We'll probably start. We've got quite a few things that we're going to go through. It's going to be more of a introduction stream because it's the first one for the algebra topic. So there should be a lot of these concepts that you guys have seen in class that you could be familiar with. And yeah, let's go and have a look at that. There we go. All right, so these are some of the topics that we're going to cover today. Hopefully we're going to get through the list. Otherwise, of course, we will start again next week with the remaining topics. It would be nice if you could let me know in the chat if the audio is good, if you guys can all hear me really well. Now, for today's topic, we're going to spend some time doing expanding and factorizing, which you guys hopefully would have done for a couple of years now, end of year 10 and throughout year 11. This is still part of the algebra paper this year. So whether you guys are getting ready for the mock exams or for the end of year exams, this is still one of the key concepts that they want you guys to know. Afterwards, we're going to go and do some indices rules, some exponent rules, and of course the opposite of that, which is log rules. In year 12, these are the new additions to algebra, which is all the log rules, and making sure that you guys are familiar solving equations where the unknown variable is in the exponent. We'll see how far we get. I've got quite a lot of questions that we can do. We're going to skip majority of our questions throughout, and you guys can later on come back to the stream and do those yourselves, or you guys can pause later on to give some of those a try. And depending on how far we get, we will also be able to do some more, depending on what you guys want to. Depends on how far we get. Okay, just a quick introduction for this video. So I'm Sel. I've been a private tutor for mathematics and statistics for about 13 years now. I've tutored for over 500 students, mostly one-on-one, but also in small groups. If you guys need to, if you guys don't already, you can also book some lessons with me privately one-on-one. And later on, I will leave a link in the description for you guys. At the moment, I don't think it's currently available while we're live. One part that I wanted to note is that it is very important that when you want to learn mathematics, that you're actively participating. And I highly encourage you guys to either pause for a minute and then continue the stream continue playing a little bit later. If you need to, do the examples with me. There's going to be a lot of time for you guys to do these examples together with me at the same time. Some of you will be a little bit faster, some of you will be a little bit slower. So that should work out really well. The most important thing is to make sure that you are learning these for long term, because we want to know how to do all these concepts at the end of the year. So come back maybe tomorrow, maybe sometime this weekend, and just skip through all the different sections. When this video is uploaded, it will have all the different sections in there that you can click on, and just do one other example there for each, just to make sure that you remember how to do all of the questions very well. Okay, wonderful. So let's start with solving some expanding questions. So here we can see in the first part here, single bracket expansion. So of course, whenever you have brackets, expanding means we want to get rid of the brackets. And the rules are normally that whatever is in front of the brackets, we multiply with each part in the brackets. So let's have a look here at the first example. We have 3 open bracket x plus 4. Now, between brackets and numbers, yeah, you guys need to always remember that there is an invisible times. So that means 3 is multiplied by, in brackets, x plus 4. And now what we need to do is whatever is in front of the brackets is multiplied with each part in the brackets. So 3 times x will give us 3x. And 3 times positive 4 will be positive 12. And that is already the first part done. This one should be pretty easy. Yeah, we can do the second one here as well. We have 5y minus 2 in brackets. And again, whatever is in front of the brackets is multiplied with each part inside the brackets. So we have 5 times y is 5y. And 5 times negative 2 is negative 10. Always make sure that you're taking the sign in front of the numbers, yeah, with them. Okay, I assume that this one would have been somewhat easy. Yeah, and you guys can also do a lot of these questions on your own. Just practice, making sure that you're very familiar with these concepts. Now, if we have double brackets and we want to expand, it is kind of the same thing. If we want to, we can consider this as one thing in front of the brackets, and we can multiply this by each part, but then we end up with brackets itself again. Now, this is definitely a good way to do it, but it's not the fastest way. And you guys probably already know by now that if you have multiple brackets, oh, are you okay, kitty? If you've got multiple brackets, then you just connect each part from one bracket with each part of the other brackets. A lot of times this is called the FOIL method, but I have also seen some other names, bear clause or something, or there's lots of different options. Now, let's have a look. If we're connecting these, x times x, well, this is x squared. Then we have x times 5, that is positive 5x. 3 times x is positive 3x. And then we have 3 times 5, which is 15. There we go. Make sure that's on the screen. Now, every time when we expand these, what we usually get with quadratics is a double up of the middle terms. So in the middle here, we can see we have 2 terms that have an x in it. And remember, these are called like terms. That is because they have the same amount, variable at the end, x, and just a different number. So those 2 terms we can add together. We can't put together the other parts like x squared and 5x because they are different like terms. So make sure that every time when you expand, you always make sure that you're simplifying at the end. So the x squared remains by itself, and 5x plus 3x, well, x is an object, so first you have 5 of them, then you add 3 of them, so we're going to get to 8 of those objects, so 8x. And of course the plus 15 at the end. And that's already the final answer. Maybe let's do number 8. Yeah. So that would be 2x plus 1 in brackets multiplied by x minus 3. Always be very careful with your negatives when you do this question. So we're going to start with the first one, 2x multiplied by x. Well, 2x times x, the numbers stay the same. So we're just going to have a 2. X times x becomes x squared. That's our first term. For a second term, we're going to multiply with the last digit here, which is negative 3. So 2x times negative 3, numbers first. So 2 times negative 3 is negative 6. And then we still have the x at the end. Sorry, there you go. Okay, once we're done with this, we start with the 1. 1 times x, that's just 1x by itself, positive 1x. And we don't need to write the 1 here because we know with variables in front, we always have a 1. It's like a hidden 1. And then we have 1 multiplied by negative 3. 1 times negative 3 is negative 3. And just like before, we need to check which one of those are like terms. So here we have negative 6 and x like terms. So we can put those together. 2x squared remains the same. And negative 6x plus x. So we're just adding the numbers in front together. So that's minus 6 plus 1. It's going to be minus 5x minus 3. There we go. You're welcome to do some of those, but I think this should also be somewhat familiar for you guys. And it's very important that you guys know how to do expanding because it will be in a lot of the questions. Right, basic factorization. We're going to get to quadratics in a moment, but for now, if we have a look at some of these, there's no square terms. I mean, in the second one there is, but we have a missing term with no number at the end. So let's just have a look at the first one. Here we have 6x plus 9. And what we can see here is that both terms share a common factor. So when we have a look at the numbers, here we have 6 and 9 are the numbers. Both of those can be divided by 3. So what we can do is we can factor out the 3. That means we kind of reverse. Yeah, this is the reverse step for expanding. So we're going to divide each term by 3 because we're taking the 3 out. So 6x divided by 3, we're just doing the numbers. 6 divided by 3 is 2. And then there is just an x in the front. That remains there because there's no x by the 3. And for the 9, the same thing. 9 divided by 3 is positive 3. So there we go. We get 2x plus 3 in brackets. And if you ever wanted to, if you're not sure, you can always double check by expanding. If you expand this, you should get back exactly what you started with, because factorizing and expanding are opposites of each other. Remember, you guys can ask any questions in chat anytime you want. If there's a specific question you wanted me to do, then we can always do that. Or if you guys have a question or wanted something re-explained, I'm always happy to do that. Okay, let's have a look at the next one. We have 12y squared minus 8y. Now again, we just have two terms, and we're going to have to find what are the factors that they both have in common. So first we look at the numbers. I'll mark them here in yellow. So that's 12 and negative 8. And if we have a look in our multiplication table, what can you divide 12 and 8 by? Preferably the highest number. Yeah, both of them can be divided by 2 and by 4. So when we factorize, we want to make sure that we take out the highest common factor. So in this case, this would be 4. Next, we will have a look at the variables. So here we have a y squared and we have a y. So technically, both of those terms have a y in it. We can divide both terms by a y. So what we're going to do is we're also going to take out the highest common variable as a factor. So that would be y by itself. There we go. And now what we're going to do is each of these terms, we're going to divide it by 4y. And see what's left over. So if we have our first term over here, 12y squared, and we're dividing it by 4y, well, let's do the numbers first. 12 divided by 4 gives us 3. And we have a y squared, and we're getting rid of a y. We have a factor of y outside, so technically one of the y's goes away. So we're left with just one more y. And if we are now doing the second part, negative 8y, first of all, negative 8 divided by 4, numbers first, is going to be 2. And don't forget the negative, of course. Negative divided by a positive, same as negative times a positive, we take out the negative 2. And here we already have one y. One other y is going to be taken away because we factor it out. So there's none left. So this is all we're going to get. All right, I think these ones are still pretty easy. Let's go to the quadratics. And there's a couple of different types. Here we have some where the leading coefficient is 1. That means the number in front of the x squared here is equal to 1. Now, for this question, whenever you see a quadratic, it is always very important for you to check, is the number in front of the x squared a 1? Or like here, if it's not visible, that means there is a 1 in front of the x squared. This is the first type of factorizing with quadratics that you need to know. And I'm going to make sure that a lot of these questions are very repetitive. So the steps that I'm going to give you for factorizing is going to be the same for majority of them, just an extra step or two. I'm just going to move them over here a bit so we have more space. So we're going to have x squared plus 5x plus 6. So this is a quadratic in standard form, something with an x squared, something with an x, and a number at the end. Now, if we want to factorize this here, we're going to end up with 2 brackets. This is our final result. We just need to remember what is in the brackets. And the way that we do that is we start by having a look at the number at the end. This is the one that doesn't have an x. Make sure you put it in exactly this order where you have the squared term, the x term, and then the number. You might have to rearrange it if you get a question like this that's rearranged. Now we're going to take the last number, which is going to be 6. And what we are looking for, I'll do it in blue. What we're looking for is 2 factors that add to 6 and multiply to 6 at the same time. So what I always do is write down the number at the end, make a line underneath it, and I'm going to list all the factor pairs to make 6. So what 2 numbers are there that always make 6? And we want whole numbers, so 1 times 6 and 2 times 3 here are the only options. I always write them down, so it's very easy for me to come and have a look which ones we need. And then we check the second part here, which is a positive 5 in the front. So here the rule is always that we want to multiply to the constant, which in this case here is the yellow, and we want to add to the number in the middle. We want to add to the number in front of the x term, not the squared term. Yeah, so these are our rules that we're going to take here. Hopefully you can kind of see that. There we go. Okay, so which one of those add to 5? Well, that is going to be 2 and 3. That works. But also 1 and 6, because we can choose to have either of those positives and negatives. So there's 2 options here. We can have 6 and we're going to have -1, or we can have +2 and +3. Now, if we're adding 2 and 3, that gives 5. That's fine. And if we're adding these 2, that also gives us 5. But remember, they have to, at the same time, they have to multiply to a +6, because we had a positive here. And if we're having a look at them, there's 6 times -1 can only be a negative. So that one cannot be the correct answer here. So there's only one option here for us. It is a +2 and a +3. Now, the way that we finish this question is we have an x here and an x here, and then filling in with the 2 numbers that we have got, which is +2 and +3. And that is everything done. So let's do another example. We have x squared plus 7x plus 12. Maybe we'll do it here at the bottom. X squared plus 7x plus 12. There we go. So again, we need to take the number at the end, the constant with no x term, and we want to find 2 numbers that multiply to get to 12 and add to our 7. And again, we're just going to start very quickly, write down our 12, and we're going to write down our factors. 1 times 12, we know it can be divided by 2, so it's 2 by 6, and 3 times 4. And I highly recommend lining these up in like ascending and descending order on the other side, because that way you know when there's no more factors. When you reach the middle, then there's no more, assuming you didn't forget any along the way. So let's have a look which one of those add or multiply to 12, all of them, and which one adds to 7. There's only one option, which is 3 and 4. Both of them are positive, positive 7 and positive 12. So we get a positive 3 and a positive 4. So we do our two brackets, x plus 3 and x plus 4. Now, hopefully this is very familiar for you guys since you've done this in year 11 as well for your algebra exam there. Now, once you have a number in front of the x squared term, this method will just slightly adjust this one so you guys can basically still do the same thing. I think you guys are pretty good with these ones, so I'm probably going to move on and leave these ones as practice for you guys, or at the end, if you guys want to do more, we can come back. Let's have a look at some questions where the leading coefficient is not 1. So the number in front of the x squared term is not 1. In this case, we can still do the same technique with a slight extra step, but it's very important that you guys always check one thing first. The first thing that I want you guys to check is, can all terms be divided by the leading coefficient? So remember, the leading coefficient is the number in front of the x squared term. So we're going to have a look at our first example here. 2x squared plus 5x plus 3. Now, the leading coefficient is 2. Before we do anything, we're going to check if 2, 5, and 3 can be divided by 2. If that's the case, then we need to do a different kind of factorizing first. In this case, it's not the case, so we can just go straight into doing our factorizing method. And it's going to be very similar to what we had before. So let me just write that 2x squared plus 5x plus 3. Move this over. Yeah, I'll have to make it a bit wider next time so we've got more space to write on. So we're going to do kind of very similar, but here, instead of having just the 3, we need to take the leading coefficient with us. So it's going to be 2 multiplied by 3. The leading coefficient multiplied by the end number will give us 6. So we now need to have all combinations to get to 6, and we've already seen that. That's 1 times 6 and 2 times 3. Nothing really changes. We still need to make 5 when we add them. So this better be the same positive 2 and positive 3 that we had in the last question. Here's the extra step that we're going to do. We're still going to do two brackets and pretty much copy the same step that we had before, x plus 2 and x plus 3. But now, because we had that 2 in front, we're going to have to kind of divide both of these by 2. And this is a little bit of a trick. As long as you divide both of them by 2, you can now simplify the fraction that comes up here. So if we simplify this, this is going to be x plus, 2 divided by 2 gives us 1. And 3 over 2, 3 and 2 are both prime numbers, so this better be already fully simplified. So we're going to get x plus 3 over 2 and leave it like this. Now, when we do factorizing, we don't want to leave any of these with decimals or fractions. So the last and final step here is, after factorizing, is any of those numbers that are still in a fraction, we're just going to move that in front of the x. And then we're done. So we're going to get x plus 1 is equal to 2x plus 3. I find this the most the easiest way to do factorizing with a number in front of the x squared term. It's the fastest as well, but there's lots of different ways of doing factorizing. So if you guys can already do these really well, you guys have your own method that works, then by all means make sure you stick with that. You don't have to change it to this, but I like this method because we basically have the same rules. We're still finding terms that multiply and add to the two numbers just like the basic factorizing. We still put them together in the two brackets the same way. There's just one extra step, which is dividing both of these numbers by the leading coefficient and then moving them in front. Now, don't forget to simplify. Yeah, so we must simplify. And that's for this step here. Yeah, if we don't simplify, like for example, we move the 2 in front here to make it 2x plus 2, then it will no longer be correct. Yeah, we need to make sure these are simplified. And if you guys don't remember how to simplify a fraction, that's perfectly fine. You guys have a calculator in this exam, so all you guys got to do is put 3/2 into the calculator, press enter, and it will still show you 3/2. All right, I think we should do another one. Let's do 3x squared plus 2x. Do we have something negative? Oh yeah, it has a negative. So 3x squared plus 2x minus 8. So we have 3x squared plus 2x minus 8. There we go, and we should be able to move over here. I think I have to draw something on the side so I can slide further. There we go. Okay. So again, the same method. We have a leading coefficient. What was the first thing that we always check? We check if the number in front can be divided by each. It can't, because 2 and 8 cannot be divided by 3. So we're going to get 3 multiplied by -8 is -24. And now what we want to do is we want to find all of the pairs again for -24. We're going to ignore the negative, so it's going to be 1 times 24. We know it's an even number, so it can be divided by 2. 2 times 12. Can it be divided by 3? Yes, 3 times 8. Can it be divided by 4? It does work. 6 times 4. And now we can kind of see again how this works from lowest to highest. And these are all the factors that we have. The only factor that could possibly be here is a 5 because it's between 4 and 6, but we know 5 cannot work. Okay, and we're going to check which ones add to +2. But now, because we have a -8 here, that means we're going to have to take one positive and one negative number. Because the only way when you multiply two numbers together to get a negative is by having one positive and one negative number. You can kind of check this every time we have a positive or negative here, and that will kind of help you. So we need to get to 2, and we can kind of check. If we go 1 and 24, we can't really do anything. Yeah, 1 minus 24 or 24 minus 1 is not going to be 2. It's going to be 4 and 6 here, right? Okay, so we're going to have a +6 and we're going to have a -4. Okay, once we've got those numbers, again, the easy method is just writing the two brackets down. We again have x, and it's going to be a +6 and a -4. Always following the same steps over and over, and with practice, you guys are able to do those really, really fast. Now, remember, when we do this, we always need to divide by the number in front of the x squared, which is going to be 3. And simplifying this in the calculator, 6/3 is actually 2. 6 divided by 3 works perfectly to make 2. And 4 and 3, they are coprime. Yeah, that means 4 cannot have the same factor as 3 except for 1. And 1 is kind of a boring factor to have. So we're going to get x minus 4/3. And the final step is, if we have a fraction left over, we move that in front of the x. So let's do that. We're going to get x plus 2 and 3x minus 4. Right, and that's it. That's all we need to do. Now let's have a look if we have a question where we do have a number in front that all can be divided by. No, that is not our next one. Let me make one up so I can show you guys what we need to do. Let's say we have 6x squared plus 15x plus 3. Now, if you do the method here, where we do 6 times 3 is 18, write down the factors of 18, which two numbers add and multiply correctly, write them into the brackets, simplify, this will not give you the correct answer. The reason for that is because we're using the simplifying part somewhere here closer towards the end of our steps. And this doesn't work if all of those numbers share the same factor. So if we have something that we can divide by, then we need to first divide everything by that. Factor that out as an individual. So for this question here, 6, 15, and 3, we can see that all of those numbers have 3 as a common factor. We can divide 6 by 3, we can divide 15 by 3, and we can divide 3 by 3. If that's the case, then what we need to do is use the factorizing method that we had first, the basic method, and factor out a 3 for each term. So we have x squared, 6x squared here, divided by 3 is 2x squared. Then we have 15x here, divided by 3 is going to be 5x, and 3 divided by 3 is 1. Remember, any of those, if you guys forget your times table, you guys got a calculator. And now what we have here is actually the exact same question that we have already solved, which was our first question over here. So we already know what that factors to, which is going to be exactly this here. So we can now have a final answer as 3 times x plus 1, 2x plus 3. There we go. Sorry about that. All right. We're pretty good in time, so we can probably do one more here. Let's have a look at the last one, 8x squared minus 2x minus 3. So we can do this one over here, 8x squared minus 2x minus 3. And we're going to do it a little bit faster. So we have a number in front of the x squared term. We're checking each number if it can be divided by the same number, which it can't. 3 is a prime number here, can only be divided by 3 and 1. So we're going to get 8 times negative 3 is negative 24. Again, what does a negative mean? That means we're going to have one positive number and one negative number. Writing down our factor pairs again. There we go. And again, which numbers now get to negative 2? Now, if we have a negative number, one small little thing that I usually think about is that the larger number will have to be negative, right? So if we have a look, which numbers have a difference of 2, that's 6 and 4. So we're going to have negative 6 and we're going to have positive 4 as our numbers. And what do? We make two brackets. We're going to write x on both sides, and we're going to make plus 4 and negative 6, which is exactly the numbers that we had. Okay, now what do we need to do next? We need to divide both by the leading coefficient, which is 8. And now not all of them are going to be, actually none of them will be whole numbers, which is fine. But we still need to simplify. 4 over 8 becomes 1 over 2. And we have 6 over 8 is 3 over 4. All divided by 4 in the first one and dividing by 2 for the second one. So we're going to get x plus 1 over 2 and x minus 3 over 4. Let's get rid of these. And the final step, after simplifying, if we have numbers left over, they move in front of the x and we're done. So we're going to get 2x plus 1 and then 4x minus 3. Okay, by knowing these factorizing methods, you guys can get up to a merit in some cases in the exam, depending on the marking schedule. It is very important that you guys get them right each time, so practicing and doing some of these questions that are on the screen. Yeah, if you guys struggle with factorizing, that is a good way to go. Make sure you do them over and over. Now, sometimes you might have questions that don't have any of the factorizing methods that we just had as a solution. And these ones are the most common one that people miss. And first, before we even start on solving those, we're going to have a quick rule on how to recognize these. Yeah. So first one, we're going to have a minus. As you can see, all of those have a minus in the middle. If it doesn't have a negative sign there, it cannot be done. Potentially, we can factor out a common factor like in the basic factoring, but it's not going to be this factorizing method. And here, this is called the difference of squares or difference in squares. Remember, difference is the answer to a minus question, the result on a minus question. That's why we need to have a minus. Okay, and the second part is we need to have both sides are perfect squares. So what that means is if we have a look at these two numbers, these are the two end numbers or the both sides that I'm talking about. Both of those need to have perfect squares. So that means we're able to write two boxes, square them, and have a minus. This is going to be your formula for solving difference of squares questions. Every time when you see a negative or you don't know what to do with factorizing, it's probably this one. This is the one that most of my students always forget about. So if we have a look at the first one, x squared minus 9, what we want to do is we want to write this first part here as something in the box squared. Well, x squared, in order to make it a squared, we better have an x by itself. If we have x in a box and we square it, then we get x squared. We're good. Now for the second part, we have 9. So what do we have to put in this box to get 9? Well, something squared is 9. That's 3. If you ever need to, if you forget your times table, if you have numbers, you can use the square root of 9 in the calculator to find what that number is, which is 3. Once we have those two, all we need to do is write our brackets again, and we use exactly the ones that we have found. Just make sure that you keep them in this, we want to keep the order. If you don't keep the order, it will not work. Yeah. Now here we have x first, then 3. So we're just going to write x and 3 into the brackets in that order. And now you can choose one of them to be positive and one negative. It really doesn't matter which one. That's all we're going to do. Now let's have a look at another question. We have a squared minus 16 and we have y squared minus 25. Okay, let's do a squared minus 16 first. Again, we're looking for something squared that makes a squared. So that's going to be a. We're looking at something that makes 16. That's 4. And we know it's a negative in the middle. Perfect. And we're just going to write two brackets and write them in the same order. A, 4, A, 4. One is positive and one is negative. And we're done. Okay, let's do one more example over here. Again, we're going to draw a quick box, square both of them and have a negative in front. And what do we square to get to y squared? Well, that would be y, and 25 would be 5. 5 times 5 is 25. And we can immediately write down the answer, y minus 5 and y plus 5. Or you can have y plus 5 and y minus 5. It doesn't matter which order. Now, this is by far, I think, the easiest factorizing method, the fastest, but a lot of students forget that these ones exist. Yeah, we're going to do a couple more. We're going to do number 7 and number 8. So we're going to have 9y squared minus 64. So 9y squared minus 64. And then we're going to have one more. We can do 200x squared plus 18. Okay, we're going to start with 9y squared minus 64. Well, again, we're going to make two squares. We're going to square them. We know there's a negative, and we're going to fill in what we need. Now here, this whole part here is now our first term. So this whole part here has to come from something in the box squared. So we need to do them separately. What number squared makes 9? That would be 3. And what do we need to get a y squared? That would be y. So you can think of this box as like in brackets, 3y squared, sorry, 3y all squared. And then the same thing on the other side. Here again, we just have a number. So what number do we need squared to get 64? Hopefully I get it right. Sometimes when I do too much talking, I write some silly numbers on the board. So we have 8. 8 times 8 is 64. And again, it doesn't matter how many things we have. It's just important to note that these are in a box. So these ones go together one by one. And we're just going to write down our two brackets, 1, 2, and write them in the same order. So we have 3y and we have 8, 3y and 8, and however you feel with the positives and negatives. Okay, now as with all of the other factorizing methods, always keep in mind that we need to first divide or take out factors that are in common. If you forget to do that, most of the time it's okay, because we are going to struggle. So let's have a look what happens if we're applying the same rule here. We're just going to have two boxes, we're squaring them, we have a negative in front. The x squared is not going to be an issue, that's just an x, here that's easy. But what about 200? What number multiplied by itself gives us 200? And the same thing, what number multiplied by 18 gives us, what number by itself gives us 18? So if we have a look here, we can use our calculator. So we can go into 18 and is this working? Yeah, it is. Okay. So we're going to go to square root, shift square root, 18. Please work, calculator. Shift, there we go. Yeah, that's working. So we've got the square root of 18. I might just have to type it on the keyboard. So it gives us 3 square root 2, or it gives us a decimal, an infinite decimal. Now that is not what we want when we do factorizing. So it's very important that when you get to the stage that you remember that you forgot to do one step, and that is exactly that you go back and check if each part has the same common factor. So let's have a look here. What common factor do we have? We have 2. We can factor out 2 from both of these. So let's do it off this one first. 200x squared. If we divide it by 2, we're going to get 100x squared. And then we're going to get 18. Well, dividing it by 2 will give us plus 9. And if you guys have paid attention, no one has said anything in the chat that I have made a rubbish example when I made it up. Of course, we need a negative, right? That was our first rule. We can't do this factorizing at all unless we have a negative. We could have factored out a negative here, but let's not overcomplicate this question. Now, if we have this now we can actually have a look at this. This one here is now factorizable. So what do we need in the boxes? We still need the x, but now we have 10 times 10 makes 100, perfectly fine, and 3 times 3 makes 9. And now we can write down the final answer here, just like before. We're going to do our brackets in the same order, 10x and then 3, 10x and then 3. One positive, one negative, and don't forget the 2 that we factored out earlier on. Cool. We need a minus, and we need both sides to be a perfect square. If that doesn't work, we can take out a common factor. If that doesn't work, you might have to think about doing a different factorizing method, or someone made a mistake. All right, how are you guys going on? How is everything all right? Are you guys all right? Is this too easy? These are some of the past exam questions that come up with factorizing. There is usually 1 to 2 of these questions in the paper, and most of the time they're going to say simplify, and then they have some sort of fraction with multiple quadratics. It's always the same step. As soon as you see these fractions with lots of polynomials, all you got to do is factorize the top and factorize the bottom. Now, some students cancel out the x squared here. X squared divided by x squared, oh, they both have an x squared, let's cancel them out. That doesn't work because here we have pluses. We have separate terms. Whenever you have a fraction, it's basically saying the top part is in brackets and the bottom part is in brackets. We can't cancel out anything that's in between brackets. Now, we still want to cancel something out, and the only time that we can cancel something out is if we have multiplication. So, instead of having a plus here, adding our terms together, we want multiplication. The way that we make multiplication, well, multiplication is times, right? So we're going to have factors. So we need to factor the top and the bottom, factorize them out. So the top is a quadratic. We're going to do them really quickly here because I assume that if you got this far in the video that you either tried all of the other examples or this is already too easy for you. So we have 6, which is 1 times 6, 2 times 3, and we need to get to 5. So the only options, is that the same example we've done before? I think it is. So we're going to get x plus 2 and x plus 3. And now we're going to make our fraction. Yeah, we changed just the numerator, and now we have to change the denominator. So x squared plus 3x. Now here, it's not a full quadratic, right? If we look at the term at the end, we have 0. Clearly, we can't have the factors of 0. That wouldn't really work for our factorizing methods. Now, we also don't have a negative, so it's not going to be difference of squares. So we're going to have to resort to our basic factorizing, and we can see both of them share an x, but no number. So we can just take out an x and make one bracket. For x squared, if we divide by x, we take one x away, however you want to look at it. We have 2 here, we take 1 out with 1 left. Here we have 1x over here, 1 goes away, so we have none left, basically like this. Or you can think of as 3x divided by x, and the x's cancel. Now, when you do these questions, you should always find yourself in a position where one of these brackets in the top and the bottom match. If this is not the case, you need to start this question again from scratch in your exam, because this is always the way to solve these questions. If this doesn't happen, then you've made a mistake. Now, before, we couldn't cancel out the x squareds because we have plus in between. Here, we can cancel things out that are the same, and the reason is that we have here is that times between the brackets. Here as well. So there's only times and divide here, allowing us to skip the BEDMAS part, we can just cancel x plus 3 and x plus 3 on the top and the bottom. And now our final answer is going to be x plus 2, which is left in the numerator, and x in the bottom. Now for the level 2 exam, often you guys have to write it in the form of ax plus b. Or in a different form, such as like a over x plus b, where a and b are integers. Now, when we have a fraction, we can always split it up as long as there's only one element in the bottom. Think of this as 6 over 3 plus 4 over 3 is 6 plus 4 all over 3. Yeah, this is how we add fractions together, and we're kind of doing the backwards way. We already have this form where we have things added and subtracted at the top and a single one at the bottom, and we're going to go backwards and split them up one by one. I guess I can leave this here. So how are we going to do that? We're going to take each one of these and just divide it by x by itself. So we're going to get x divided by x, and we're going to get 2 divided by x. And now sometimes some of these can be cancelled out. So x divided by x, right? Make sure you don't say 0 here. Yeah, if we have 3 divided by 3, that's 1. 4 divided by 4 is 1. X is a number, so it's 3. So it's any of those divided by itself, which is going to be a 1, plus 2 divided by x. As a little bonus, what number can x not be? Well, we have a bit of an issue here. Dividing by x, we can divide by any number except from 0. So x cannot be 0. You don't have to write these down. That is usually not required, but it's good to think about it when you have some kind of functions or equations. If we're having a look at the second example, the numerator here has a negative, and we've also done this example earlier on, x squared minus 9. So we look what the first one and the second one squared are. What squared makes x? That's x. What squared makes 9? That is 3. And one of them is negative and one of them is positive. I think that's the easiest and fastest factorizing method, if you're lucky to get difference of squares. You just need to identify when to use it. Now for the denominator, we have a quadratic. As always, we have a 9 at the end. So we're going to write down our factors of 9. So 1 times 9, we're going to get 3 times 3. Now, I already know it has to match with one of these because that's how these exam styles are kind of made. So I can kind of, if I'm not really sure which one it is, kind of see that it has to be 3 and 3. But again, how do we figure that out? It needs to be -6. While multiplying together makes a positive. So if we get a positive, that means both of them have to be positive or both of them have to be negative. Well, in order to get to -6, then we better have -3 and -3. So x minus 3 and x minus 3. Make sure when you do these questions that you're not forgetting about the plus and minus. Yeah, forgetting a negative is one of the most common mistakes that I see in factorizing. And again, we check once we factorize the top and the bottom, we see that 2 of them are exactly the same. So that makes us very happy because that shows us that we've done a good job. We can cancel them out and the final answer is just whatever is left over. So we're going to get, I kind of don't have that much space, but it's going to be x plus 3 divided by x minus 3. And that's our final answer. Splitting this one like we did before would not make too much sense. And that's because there's a plus or a negative in the bottom. Yeah, if you have that in the bottom, you can't split it as we did before. Well, technically you can. It would just be x over x minus 3 and then 3 over x minus 3. But that doesn't really simplify it because none of those can now be cancelled or made easier. So that's why we don't do that step here. And the final question, again, we have ourselves a quadratic in the numerator and the denominator. I would do the bottom first because there's no number in front of the x squared. Remember, that's what you always check first. We have a 1 in front, so that's good. We want the factors of 6. So that's 1 times 6 and 2 times 3. Making 5 is again x plus 2 and x plus 3. Kind of move over a bit. There we go. And the numerator, yeah, we have a number in front of the x squared. What's the first thing you always check? When you look at these, you need to check if all of the numbers share the same factor. Here, 7 and 3 are prime, so we're good to go. We don't have to do that. So we're going to do 2 times 3 is 6. So it's the same factors again. And the ones that make 7 is 1 and 6. Let's make this one here over here. So we're going to get ourselves x plus 6 and x plus 1. Yeah, cool. Okay, and what is the step that we need to do? Well, it has a number in front of the x squared term, so we're going to divide both of those by 2. Simplify those, which then gives us x plus 3 and x plus 1 over 2. And moving those, sorry about that, moving those in front for the final answer, we're going to get x plus 3 and 2x plus 1. Awesome. Now we can write those in here, x plus 3 and 2x plus 1. Okay, again, we see 2 of those match, so we can cancel those out and we're happy. Final answer is going to be 2x plus 1 over x plus 2. Some of these, if you get all the factorizing correctly and cross it out, can be a merit, even though it's mostly an achieve for level 2. All right, we're about halfway through. We've done all our factorizing, all of our expanding, which is the absolute minimum requirement for most of the questions in the exam. Now the second part, and this is the new part for level 2, which you haven't really done too much in the previous years, which is the exponent rules. I've kind of written them all down already, so we don't sit here for ages writing them down. But I just want to quickly remind you of most of them. So in the top here, we have the rule when you multiply things together with the same base. And here a is the base and x and y are the powers. So they need to have the same base. If they don't have the same base, this doesn't work. So we have a to the power of x times a to the power of y. What we do is we add the powers together, so it's x plus y. And just like this is times, the opposite, of course, is divide by. So the rule is probably going to be minusing them. Let's make it a little bit bigger. There we go. The third rule is if we have a power to another power, and you can identify that if you have brackets. Yeah, if you have brackets and a power outside, this rule here means that we multiply the powers together, a to the x times y. If we have multiple things inside a bracket, then we need to be careful. If we have a plus b to a power, then we have a problem. This cannot be done with these rules. As soon as you have a plus in there, we've got a problem. This is called binomial expansion if you want to have a look at this. But basically, this is not going to come in any of your questions. But just as a reminder, there's a plus in there, so the rule that we have here does not apply here. Let's have a look at the rule here. We have a and b together inside the brackets being multiplied. That means n here is applied to a and n is applied to b. We get a to the n and b to the n. Yeah, a lot of students here do a to the n plus b to the n, which is incorrect. Yeah, so if there's a plus or minus, we cannot use this rule. Okay, number 5, if we have division, and here it's kind of the same as this one, but I like to have them a little bit separate because students that usually see this as division don't usually transfer this to this. So if we have a fraction, then what we have is we can have the power goes to the top and the power goes to the bottom. Yeah, we have a to the n and b to the n. Once we look at these, there's just one extra kind of rule, and that is anything to the power of 0 is 1. And this one helps you a lot also next year and also in calculus. And now there's some rules with negatives, and we're going to have a look at lots of examples in a second. But there's some examples with a negative power, right? And I think even though these rules are written in a very specific way, I like to have a couple of extra rules just to kind of see what all of these different examples are. So if we have a negative power here, a to the negative n, all that means is that the negative switches where this comes in a fraction. If we just have a number to some negative power, that means 1 divided by, and we just copy the base and the power. So the negative here stands for the 1 over part. If we already have a fraction, then negative powers are very easy because all you got to do is write them in the other part of the fraction. So here we have a to the negative n in the numerator. Taking away the negative means it goes into the denominator. Same with the b to the negative m. That just means we switch it to the numerator and don't worry about the negative anymore. And the last rule that we have is when we have a power that's a fraction. So if we have a fractional power, it is there's a special rule, and you usually get this rule in an exam. But the thing is, when you look at these, I don't really like memorizing this. And a lot of my students don't remember this rule either. So what I want you guys to remember instead is just the fact that the square root of x is 1/2. The square root of x is x to the power of 1 over 2. And the reason why I want you guys to remember this is because you can match the formula yourself. We know that a square root would kind of have a 2 there. Well, we see a 2 over here. So those go together. That's the m and the m here. And on the other hand, we have a 1 here. Well, there always has to be something inside the radical under the square root, for example, so we can kind of see where they come from and match them ourselves. I'll make them green. There we go. So as long as you remember that the square root of x is the same thing as x to the half power, then you should be able to do any fractional power question, even without the formula sheet, if you guys happen to lose that one. Okay, now these questions are achieved level questions in the exam. So most of the time it's very important that you guys get these right in order to pass the paper. I recommend doing them step by step and very slowly to make sure that there is no issues. Don't forget any negatives. So let's have a look at the first question over here. I'm going to go and zoom in a bit so we can do them one by one. So what rule do we have here? The first thing that I see is that we have brackets. So what was the rule? Everything inside the brackets is to the power of 6. Here we have a squared, so that means we have a power to a power. And if you remember, that means we multiply the powers together. So we're going to get x to the power of 2 times 6, and simplifying that is x to the power of 12. And that's already done. Next question here. Well, what do we see? We again see brackets with an outside exponent. So that means everything in the brackets is going to get squared. And here, the y to the power of 3 is of course one object, because we are multiplying 4 and y cubed together. So that means the 2 first goes for the 4, and then to this object here, which is y to the power of 3. So we're going to get 4 squared, and we're going to get y cubed all squared. And when we're here, now we can apply the rule again for this one, which means we have a power outside and or a power to a power. That means we multiply those powers together. So let's do the 4s. 4 times 4 is 16, so we got that. And y to the 3 all squared means we multiply the powers, so 3 times 2 is 6. So we're going to get y to the power of 6. Now let's have a look at the next one. Well, we have a square root. What does that mean? If you remember the rule, it's going to be to the power of half. So we're going to get 25x to the 6, all of this to the half. Because the radical, the square root, goes over everything. That means all of this has to be inside the brackets. Now, how do we go from here? Well, we're going to have, again, a power applied to multiplication in the brackets. So what does that mean? The half goes to the 25, and the half goes to x to the power of 6. So let's write that down exactly like that. 25 to the half, and then multiplied by x to the 6 to the half. And then we can do questions one by one. If you want to, you can put 25 to the half power into the calculator. But because we know that the square root is to the power of half, we might get to 5 without the calculator. But feel free to just chuck it in the calculator if you need to. Okay, the next part we have, again, a power to a power. X is to the power and the whole thing is raised to a power. So what do? Multiply those together. We're going to get x times 6 times a half. And again, you can just use the calculator if you're not sure about how to multiply by fractions. So that is 5 to the power of 3. And again, you can put this, 5 x to the power of 3. Forgot the x. There we go. Okay, next question. Now, we need to remember x squared, or the square root of x, has the power half. So we can match the number in front is a 2, and that's the bottom. So that means here, that's this number here. That needs to be in the bottom of the fraction. First thing, we're going to put everything in brackets because the root goes over the whole thing. So we're going to put the whole thing in brackets, which is 64x to the 6. And now this number here, shows us that it needs to be a third root. So that's to the power of 1 over 3. Okay, now what do we have? We have terms multiplied together. We have an outside power. So you should know very well by now that this now goes to each of the parts inside the brackets. So let's write them down. We have 64 to the 1 over 3 power, and we have x to the 6 to the 1/3 power. So what do we do now? I mean, so far we've done quite a few of these questions. So we can do 64 to the power of a third in the calculator. So which number multiplied by itself gives us 64? And I think that is 4. Is that correct? No. So we can go and have a look at the calculator. We can type in 64 and then to the power of 1 over 3. It is 4. Whoops. Okay. What do we have here? 6 to the power of a third. So that means we multiply our exponents. So 6 times a third is 2. So we're going to get x squared. There we go. Wonderful. Okay. Now, when we do these questions, remember to always do them step by step. So over here, we have fractions, but we know what rules we have. Yeah, when we have fractions, that means that the power goes to each of these numerators and denominators. So we're just going to do exactly that. So we're going to get 3 applies to the numerator and 3 applies to the complete denominator. So we're going to get 3, I'll do it in blue, sorry, 3 to the power of 3 divided by, now x squared is the denominator here, and we're going to apply the 3 to all of it. It's very important that you remember when you do these questions, that you remember that everything in the numerator or in the denominator is separate. And it's kind of treated as one brick or one part that is together. So if we do the top here, 3 times 3 is 9 times 3 is 27. You can also use the calculator. And at the bottom here, we have an x squared to the power of 3. So again, we have a power to a power. So what do? We multiply the powers. 2 times 3 is 6. There we go, and we're done. Now, next question here. We have a negative power. Well, doesn't matter. We're just going to do exactly what we did all the time. We're going to apply it to the numerator and we're going to apply it to the denominator. So what do we get? 7 to the negative 1 divided by the whole denominator to the negative 1. And what did we say a negative power means? Well, that just means we just switch them. If it's originally in the numerator, we flip it and it goes in the denominator. And the other way around. So very easy, the 7 goes in the bottom and we just do the same power, just not negative. And then here we have x squared, which has the same power, well 1, but it's positive. You don't really have to write to the power of 1, but either way you get the same idea here. Either way you do power to a power again at the top, or you remember power to the power of 1 we don't need to write. And divide by 7 and we're done. Okay, now what do we have here? We have something with the same base and it's being multiplied, so we can multiply those together by adding the powers. So we're going to get x to the power of 3, and then we're going to add negative 2. Well, that's going to give us x to the 1. We don't need to write it, so we can technically just leave it away, which is just x. And then lastly, we can just do numbers like we normally do. 5 times 3, you can also start with those. 5 times 3 will be 15. And just keep that in front. And you're done. Okay, the next one is again a fraction. What do we see? We see negative powers. So what do we know about negative powers? Very easy. It means they go into the numerator. And here's a mistake that a lot of students do. What they're going to do is they're going to keep the x here and they're going to move the 5x squared into the numerator. Now, have a quick think why that doesn't work. The reason why it's incorrect here is because this exponent here is only for the x. There are no brackets here. If we wanted it to be for the 5 and the x, then we would have to make brackets here. But those brackets don't exist here. So the negative 2 exponent only goes for the x. That means only the x is the one that switches places. So let's put the x to the top with a positive power. Well, the 5 has to remain in the denominator here. And of course, remember there is a times between those. So what do we do next? Well, we notice that this here and this here has the same base, x times x squared. You might know it's x cubed already because you've seen this a lot, but remember we do 1 plus 2 in the numerator because we're multiplying terms with the same base. Some of the exam questions are of course a little bit longer. Yeah, so let's maybe do some of these questions here. However, if you follow these rules, you'll be perfectly fine at finishing all of those questions. Just do them one by one, step by step. Let's do this top one here. 49 x to the 4 divided by x to the negative 2, all to the power of half. Now, there's a lot of steps that you can do. There's a lot of different orders that you can do in. But what I like doing is I like to get rid of my negative powers. So what do we get? We're going to get 49x to the 4 divided by, and now x here has the negative power. That means x is going to move into the numerator with a positive power. And well, what is at the bottom here? A lot of people usually say, well, it's 0, right? Because nothing is left. But remember, we're not adding or subtracting. We're dividing by it eventually. So that means here we would have a 1 left. Basically, there is no fraction. If you want it, you can just leave it like this. Over 1 means we have no more fraction. So if we leave it like this now, to the power of 0.5, some of you might notice that 0.5 here is a half. It doesn't really matter. We can just use the calculator just like before. Yeah, so let's just leave it at 0.5. Doesn't make a difference. Now, what do we have? Again, we have something in brackets multiplied to a certain power. Well, it doesn't matter what the power is, if it's a fraction or decimal, we know what to do. It goes to each part inside the brackets. Now, we can do this, or we can do another step first. You probably have already seen the other step that you could have done perfectly fine. It doesn't really matter in which order you do it in. So we're going to get 49 to the power of 0.5. We're going to get x to the 4 to the power of 0.5. And we're going to get x squared all to the power of 0.5. Right, very good. Now what's the next step here? Well, all we got to do is find the 0.5 power of, 49 to the power of 0.5. It's a square root of 49, so that's 7. And then again, we have here power to a power. You should know by now that that is multiplying. 4 times 0.5 is 2. And the same rule applies for the next one. Power to a power. So we're going to have 2 times 0.5, which is 1. So we just have x by itself. And finally, to take this home, we have x squared times x. They are multiplied terms that have the same base. So we add the power at the top. 2 plus 1 is 3. Now, again, it doesn't matter in which order you do this. If you see here, we have x to the power 4 times x squared. We could combine them by having x to the power of 6 first and then do the next step. It doesn't really matter what you do first. Also, here we have a fraction. If you think first, well, I don't like having a power outside, you could do the power to the top and the power to the bottom. In the end, it's going to come to the same answer, and you can choose which steps you like to do. All right, there's some more for you to practice, so you can pause here anytime. And if you've made it so far into the stream, it would be amazing if you could give it a like, or later on, if you're watching this in the future, you can also still comment any questions that you might have. I read the comment section very often, so I'll be able to help you guys out. Okay, now for logs, we have about 40 minutes left. So let's have a look at some log questions. Very often you have some of these in a formula sheet, but I'll have to think. The level 2 one, does it have it in the formula sheet? I'm not 100% sure if it does. But these two here, together with the last one here, these are the most important one for your end of year exam. While all of them are still required, yeah, some of those are more important than others. I think actually that this one here is in the formula sheet. It might just have some very slightly different numbers or letters, sorry. Okay, so what is so good about logs? Logs are a different kind of number or different kind of function that we have in mathematics that has a very, very unique way of dealing with multiplication and division. If we have a look here, if we multiply two numbers together and then take the log, that is the same thing as taking the log of each first and then adding it together. So what we're kind of doing here is we're splitting a multiplication question with potentially very large numbers into an addition question where we have two parts here. This is why log was used so much in the early stages of mathematics when there was no calculator, because when we have very large numbers, let's say 6-figure numbers, multiplied with each other, that would give you a very, very large number. That was something that was very, very difficult to do back in the days. So they had certain massive, like a, what do you call it? Like a dictionary where you can look up log numbers and so on and kind of transform them into these. Now, we're not going to worry about any of those. We need to have a look at our rules. So if we are dividing anything with log, that means we're going to end up minusing them separately. And what I just want to note here is that the little b here, I always use a b because that's really easy to remember. That's the base. Whenever we have a log, we have a base and we have a number. Now this here can also be a special number. A lot of the times when you have logs, people are not very happy with what number people choose as a base. In computer science, a lot of people like using log 2. A lot of mathematicians like log 10. Also statisticians like log 10. While the physicists usually like log e. E is a special number that you guys have first been introduced to this year. So e is the log e is actually ln, which is the natural log. So if you guys ever see ln, that's the same thing as log with a base e. And there's one more thing. Some people just write log 10, and what they actually mean, or let me do a different number, log x. What they actually mean is they mean log base 10 of x. So if there is nothing written, because mathematicians are lazy, that usually means we have log 10. If you're in computer science or you're doing coding, then it's often log 2. So just to confuse you, always write down your base is the moral of the story. Okay, let's have a look at the next rule. And it's looking very complicated with all these rules, but it's really important that you just understand the concept of what they're doing. That's why I'm kind of marking them in different colors. Here, the concept here is that if we have something with a power, and again, in level 3, there's lots of things with a power. If we apply log to it, that means that power moves in front. It's multiplied in the front, just like this. The dot there is multiplication, of course. Yeah. Can make it like this, multiplication. There we go. You're going to use this one quite a bit where the power moves to the front. And that is actually one of the best properties with logarithms. The next one is a base change formula. Some schools kind of go through them, some schools don't. So I'm just going to leave that one there and not really talk about it. But if you want to change this number at the bottom, the b, to something else, let's say a k, then you can apply this formula and k can be any number. So don't worry too much about this one. All right, let's have a look at the next. Let's put this in brackets. This one here is kind of like a special rule. Any log, it doesn't matter what base you have. If you do it of 1, if you have a 1 there, the answer is always 0. And the second special rule is that if you have the base and the number here matching, then the answer is always 1. And some of those are very important to memorize. These ones are definitely not in the formula sheet. Yeah, you need to remember these ones. These are very good when there's some of the merit questions in the exam where you have to simplify logs. Okay, finally, the question that's often in the exam, which is this one here. you can just copy exactly what they are. We have two parts here. We have the left-hand side and the right-hand side. And these are equivalent, which means you can change from one form to the other. Often when you see something with log, you can transform it into this, which does not have a log, and the other way around. And often in questions in the NCEA exams, this is the only way to solving some of those. When you want to solve something with log and an x in it, and you want to solve for x, this is usually the go-to rule that you should look at. Right, let's have a look at the next few questions. We're just going to go through them and make sure you're memorizing those rules as we go. So the first one here, over here, we have log base 2 of 4 plus log base 2 of 2. So we have ourselves the same base, which means addition becomes multiplication. Yeah, that's our first rule over here. Addition becomes multiplication inside the logs. So we're going to get log, same base still, but we're going to get 4 times 2. So we have log base 2 of 8. Now the next question has a negative. It's the same thing. We have the same base. We have a negative. Negative becomes division. So we're going to get log base 5 of 25 divided by 5, or you can write it as a fraction. Perfectly fine. Log base 5, 25 divided by 5 is of course 5. And now let's have a look at this one here. This is usually where students stop. And this is why it's so important to have that extra formula in your head, because log base 5 of 5 is equal to, let's have a look, bases are the same, 1. Sometimes you can simplify further. At this moment, it's just important that you remember the rule here, but you could rewrite this one using this last statement here. Often when you do logs, it will be very difficult to put these in the calculator. Some calculators don't actually allow you to put log base 2 in the calculator. Let's have a look here at the calculator that I've got on the screen. Yeah, if you press the log button, which is over here, this is always going to be log base 10. And we can check, because if the base is 10 and the number is 10, the answer should be 1. There we go. So the base is always 10. So you can't usually put log base 2 in the calculator. If you wanted to use this in the calculator, you would have to use the base change formula, which is this one here first. But usually that is not required to solve any of the questions. So instead of using the base change formula, we're going to go to the last formula that we spoke about, which is rearranging our question in terms of powers rather than having logs. So we could do that here, but let's just leave it. We're going to leave everything as it is, as long as it's easy. Okay, log base 3 of 9 squared. Well, we can see there's something with a power. What is the rule when we have a power? A power moves in front. So what does that mean? We're going to get log base 3 of 9, and the 2 is multiplied in the front. So we're going to get 2 times log base 3 of 9. And what else can we do? Well, 9 can be written as a special number. 2 log 3 base. Okay, now 9 is a square number, so we can write this as 3 squared. So if we have 3 squared, again, what happens to a power here? A power would move to the front. So we're going to get 4 log base 3 of 3. And what is log 3 base 3? You should know that by now is 1. This whole thing here is 1, which makes the last part here 4 times 1, which is 4. We can do the same thing in the previous question here. So if we write log 2 is of 2 to the power of 3, which is 8. Sometimes it's a little hard to recognize these, but those 2 to the 3, 3 to the 3, those numbers keep coming up, so sometimes you might be able to remember. Now again, we have a number here in the exponent, so that number moves to the front. So we're going to get 3 log 2 of 2. And what is log 2 of 2? That is 1. So we're going to end up with 3. Okay, let me have a look. What other questions do we want to do? Just so we have enough time at the end to maybe do some questions that you might have. All of them are just following the rules. Yeah. Let's do number 10 here, because it's a little bit different. So we're going to get log base 3 of x plus log base 3 of 3 is equal to 2. Okay, so let's have a look at this question. First of all, what do we note? We see it's added. Well, we need to check if the bases are the same, and as long as they are, we can put them together. So how do we put them together? Well, adding logs is the same as taking the log of multiplication. So we're still going to get log base 3, but we're multiplying 3 and x together. So it's these parts here are multiplied together over here. Equals 2 still. Okay, what's the next part? Well, we can simplify it a little bit more. 3x equals 2. And now what we see here is we have an x inside the brackets. So we can't really get that out. We need to get rid of this log. And the way that we always do that is by using that formula that we have at the end. Now, even though it's probably in your formula sheet, I usually like remembering how that formula works. And as long as you remember that we have log base of a number, yeah, then we can always figure out what it has. This is the base. So if we write this in a different way without log, this is called the base. So it's going to be the base that has a power. And now it's just the confusing part. The power is on the other side. So we're going to have b to the y is equal to x. I usually just remember this is the base and I need to use the opposite, and then the x is the only thing left in the equal sign. So if we apply this here, well, what's the base? We have the base is 3, so let's take 3. We need to take the power, which is the opposite side, squared, which is this part here. And then what's left, that is on the other side of the equal sign, which is 3x. And now this is something we can solve. Well, 3 squared we know is 9. And 3x on the other side. And now we can easily finish this question off. Well, we have 3x, so we need to divide by 3. We're going to get 3 is equal to x. There's a couple more questions where you have to use this rule, changing over. So we could do this top one real quick. So we have log base 2 of x is equal to 5. Again, 2 is the base, so let's write that down. The opposite number is the power, and then equal to whatever is in the brackets. Now, a lot of people are a bit lazy, they don't write the brackets. If it's just one term or one number, often we leave the brackets out, but technically that's what's in the brackets. Well, and 2 to the power of 5, you can put that in the calculator, is 32. Wonderful. Okay, let's do the last one, but we're not actually going to solve the whole thing. We're just going to replace using that formula. So what do? We have 5 as the base. So we're going to write 5 to the opposite power is equal to what's in the brackets. And surely you guys can solve this one already. 5 times 5 is 25 times 5 is 125 is equal to x plus 1 minus 1 on both sides. 124 is x. Okay. We have our last topic for today's stream, which is solving equations with an x in the power. And now these questions often require you to do a certain method using logarithms. Every time you have a variable in the power, we need to take it out of the power to solve. So let's have a look on how we do that. Our first example here is 2 to the x is equal to 10. And well, if we look at this, 2 to the 1 is 2, 2 squared is 4, 2 to the 3 is 8, and 2 to the 4 is 16. So clearly it's somewhere in the middle. However, that doesn't seem to really be working. We don't know what it is. It's going to be some kind of decimal. So what are we going to do? We need to use a different method. We need to solve using logs. Now, what did we do before? Before, we had something like x plus 1 is 125, and we did minus 1 on both sides. Doing minus 1 on both sides meant they stayed the same. The equal sign is still the same. This side and this side have the same weight taken away, which is 1. So as long as we do the same on both sides, nothing changes. And that also applies to applying logarithms to each side. So what we can do is we can have log of everything on one side, and then we have log of everything on the other side. And the reason why we want to do this and how we know when to use it is every time there's an x in the power, we use this method. And the reason for that is because we have that perfect special property for logs where everything in the power is multiplied to the front instead. So we're going to get x multiplied by log of 2. And now you might be asking, why am I not writing a base? Remember how I said that mathematicians are lazy, and if we don't write a base, we mean base 10? Even if I have base 117 or 179, it really doesn't matter, because as long as I do the same base on both sides. However, I want to use log base 10 because that is the log that the calculator can do. Yeah, we have to use log base 10, which is usually just the log button on your calculator. That's why everyone just leaves it as log, but do keep in mind that that means base 10. So what do we get? We have x times log 2 is equal to log of 10. And now, even though we know what log 10 of base 10 is, we're just going to keep it like that. As if we don't know, we're going to leave it because we are going to have the same step procedure every single time when we solve these. So here we want to have x by itself, and log 2 is just a number. So if this is just a number, we can divide both sides by it. So we're going to get x is equal to log 10 divided by log 2. And because they're the same base, we can just put this in the calculator just like that and ignore that we could simplify one of them. So let's have a look over here. We're just going to put in a fraction. And at the top, we're going to do log 10. And in the denominator, we're going to have log 2. Oh, log 2. Can it please work? 2. There we go. And we're going to press enter, and the answer is going to be 3.32. Two decimal places is usually very good to be rounding to. And that's all you guys got to do, and it doesn't matter what you guys chose for the base. Now, a lot of the times mathematicians like using natural log instead of log. So remember, the natural log is the same as log with a base of e, the special number. Here e is Euler's number, which is roughly 2.7. You can have a look in the calculator what that number is exactly. So instead of applying log to both sides, a lot of people apply the natural log on both sides. So just for practice, let's do the same thing. We have 2 to the x is equal to 10. We're going to have the natural log applied to one side and the natural log applied to the other side. And then what did we do? We have a number in the numerator that goes in the front. That's why we do this, which is going to be x times the natural log of 2 is the natural log of 10. I'm going to try not to have my face in it too much. And what do? Natural log of 2 is just a number. So we're going to divide by the natural log of 2. And it's very much the same as the other question if you look at it. If we get to this question here, we can do the same thing. We can go to our calculator and we can see it's not going to change anything. We're going to use natural log, which is over here. Is it going to work? Yes, natural log of 10 divided by the natural log of 2. Enter, and it's the same number. To those who know the base change formula, that should come to no surprise, because if we have a look here, if we're dividing two logs, as long as they have the same base, it doesn't literally matter at all what this base is. The previous question can have any base. Okay, let's do the next question over here, which is 5 to the x plus 1 plus 50. 5 to the x plus 1 equal to 50, I mean. So again, what we have here is we have a number in front, a number in the numerator that we don't know, the x variable. If we want to know what variable is that is in the power, we need to apply log to both sides. Now, you're going to see me use natural log all the time. I just write natural log automatically, so don't be afraid to use natural log instead of log or whatever you prefer. Now, next part, and the steps are always the same. So solving these over and over will help you get the answer here easier. So we're going to multiply by x plus 1 in the front. So x plus 1 in the front, natural log of what's left. But be careful, this whole thing here, x plus 1 is an object. This whole thing moves in front. And every time there's plus and minus, when we want to say the whole thing, we have to, of course, have brackets. And it's multiplied to this. So we're going to get natural log of 50 on the other side. And, well, what do? Every single time it's the same. The steps are the same. We have natural log here. We're going to divide by it. So we're going to have x plus 1 left over is the natural log of 50 divided by the natural log of 5. Well, and we have a plus 1 here. How do we finish this question off? We're going to do minus 1 on both sides. And before even putting it in the calculator, I'm just going to do minus 1 at the end. And then we can put that in the calculator. So if we go to our calculator, we're going to go fraction, natural log, please, thank you, of 50. And then in the denominator, we're going to go natural log of 2. And then minus 1 afterwards, which is 4.64. So we have x is roughly 4.64. 2 decimal places. Okay, wonderful. Now, let's have a look what other questions we have. Yeah, I think I just need to do one more question with you guys at the bottom. That will be the last part. And that is basically just one extra step that we need to do. So let's have a look here at 5 to the x plus 4 is equal to 20. When we apply log to both sides here, it's not going to work. So let's have a look why. If we apply log to both sides, 5 to the x plus 4 is log of 20. Here we still have an x in the power, but we can't move this one over because this part here has a plus in it. We can't touch this unless it's multiplication when it comes to the powers. Very similar to simplifying. So this doesn't work. So whenever we apply log to both sides, we want to make sure that whatever we want to move the exponent out, yeah, here x to the x in the power, that's what we want to get out of. So we need that by itself. Yeah, so we need this by itself. Yeah, so we need to do some algebra to move some things around. So let's do that. 5 to the power of x is equal to 16. Well, we're going to have to do minus 4 on both sides. I'm pretty sure you guys are pretty good with that. Minus 6 and minus 6. Of course, minus 4 and minus 4. Sorry, guys. Awesome. Okay, and now we have this part by itself, and now we can apply natural log on both sides, which is ln 16. Why do we do this? Remember, the reason why we do this is because we have x in the power, and every time we have in the power, it moves to the front. You guys have to be very confident with these kind of questions because these steps are always the same. The minute you've got something that is a variable in the numerator, you separate it, log on both sides, and then solve it. The power becomes in front, just like all the other questions. And what's the next step? Well, just like all the other questions, ln 5 is a number, so we're just simply going to divide by it. Very good. And we can go to our calculator to get our final answer. So let's finish that question off by going into ln natural log. I have to press the button here. Yep, there we go. It works now. 16 divided by the natural log of 5, which is 1.72. So x is roughly 1.72, 2 decimal places. Okay, fantastic. Okay, let's have a look at the last question here. 7, let's put it over here. We have 7 times 3 to the x minus 1. 7 times 3 to the x minus 1. Minus 5 is equal to 16, right? Yes. So, well, what do we have here? Again, we have an x in the numerator, not in the numerator, an x in the power, yeah, an unknown. And if we want to solve for it, we already know the only way to do that is to do log on both sides. So if we want to use log on both sides, this term here has to be by itself. So what are we going to do? We're going to have to do plus 5 on both sides to get rid of the plus 5, or the minus 5. And we need to get rid of the 7 times. But remember, when we're solving, we're using BEDMAS backwards. So we first have to do plus and minus. So we're going to get to 7 times 3 to the x minus 1 is equal to 21. And now we're going to divide both sides by 7 to get rid of the 7. So we're going to get 3 to the x minus 1 is equal to 3. Now, there is a little trick here that we're going to explore in just a second. But remember, you can solve all of these questions just by going ahead and mindlessly do our steps. We separated 3 to the x minus 1. Now what's the next step? Log on both sides. So we're going to have natural log of 3 to the x minus 1 is equal to natural log of 3. And again, why do we do that? Because then we have a power that moves to the front. Every time we have log, the powers move to the front by multiplication. So we're going to get x minus 1 times the natural log of 3, which is the natural log of 3. Well, what are we going to do? We're going to divide both sides by the natural log of 3. Well, dividing it by itself will give us 1, and we can take the number home by doing +1 on both sides, which is x is equal to 2. Now the little trick that I wanted to talk about here, so this is a little trick here to make it a little bit faster. As soon as we have a question that has the same base on both sides, the only way that they're going to be equal is if their powers are also the same. So what we can do here is 3 is to be 3, that's the basis, that's definitely true. So we can use our trick. And then we have x minus 1 as one of the powers, and that should be the same as the other power. And remember, 3 with no power is the same as like 3 to the power of 1. So we're matching the powers here. X minus 1 is 1, and that means we're going to get +1 on both sides. We get the same answer. But it's not too important. You can just blindly remember how to do the log on both sides to solve these kind of questions. Yeah. Being able to solve a question using log on both sides is easily a merit or higher question in the exams. So studying this well and making sure that you guys are well aware on how to solve these questions will help you guys a lot. Awesome, wonderful. Now we have gone through all of our topics that we wanted to. We've done a lot of examples for everything. So please do remember to go through some of those if you were struggling with any of these. Make sure you go through 1 or 2 examples of each category a day, because that will make sure that you're well set up and prepared to pass the algebra exam at the end of the year. Right, are there any questions? Right, so what we'll do is I'm going to end the stream here, and please do remember that we have our level 2 stream every Friday from 5 to 7 p.m. Yeah, so if you would like to ask questions about certain exam questions or anything like that, feel free to join and we can add them at the end. And also, we're also going to be covering the calculus level 2 content and the probability level 2 content. And if you guys are keen, we can do a lot more harder questions as well. There's also going to be some videos coming where I go through the achieved style questions, the merit style questions, and the excellent style questions for each of the topics. So make sure you stay tuned to that because those are a little bit more individualized to your strength. Today was more about the absolute fundamentals, the absolute basics for algebra. I'll see you in the next video next week. Bye-bye.